Let f from R to R be defined by f of x is equal to 2x plus 6, which is bijective mapping. Then f inverse of x is given by. Okay, so let's see how to find out this. First one is let's write f of x. F of x is what? F of x is equal to 2x plus 6. So consider f of x as y. So you get y is equal to 2x plus 6. 2x plus 6. Further, if you solve, we have to solve this for x. I'll write 2x plus 6 is equal to y. 2x plus 6 is equal to y. Now, first step is 2x is equal to y minus 6. After that, if you solve this for x, x is equal to y minus 6 divided by 2. In fact, this is what our inverse of x, but y is the new variable that we have taken, so we have to convert that into x. So we'll consider this as one more function. So I'll write this in red color. So g of y, I'll consider this as y function. So g of y is equal to y minus 6 divided by 2. Y minus 6 divided by 2. Since we are focusing on f inverse of x, I'll write here f inverse of x. F inverse of x is equal to, now whatever we have got g of y, that we have to write in terms of x. In place of y, I'll replace x. F inverse of x is equal to x minus 6 divided by 2. So this is what our f inverse of x. Do we have this option in yeah, so we don't have this option, so we have to solve further. Let's solve further. If you split this, we get x by 2 minus 6 by 2. So we get x by 2 is nothing but x by 2 as it is. 6 by 2 is 3. So x by 2 minus 3 is the correct answer. That is option A, x by 2 minus 3 is the correct answer. Now the extension question for you all is, f is from real number to real number. I want you to find f inverse x for f of x is equal to 3 minus 4x. 3 minus 4x. I want you to find f inverse of x for this. Follow the same procedure and find f inverse of x for this. Next question. If 3 tan inverse x plus cot inverse x is equal to pi, then the value of x. Very simple problem. Let's see how to solve this. First, let us write this. So 3 tan inverse x, 3 tan inverse x plus cot inverse x is equal to pi. Okay, now if we replace, okay, let's not replace. 3 tan inverse x, I'm going to write this as sum of 2 tan inverse x plus tan inverse x plus tan inverse x plus cot inverse x. Cot inverse x is equal to pi. Is equal to pi. Now, so there is a relation that is tan inverse x plus cot inverse x is equal to pi by 2, 90 degree. So what we can do here is, in place of tan inverse x and cot inverse x, we can replace pi by 2. Okay, so let's replace that. 2 tan inverse x plus pi by 2 is equal to pi. Now, if you transpose pi by 2 this side, so 2 tan inverse x is equal to pi minus pi by 2 we get. So what is 180 minus 90? It is 90 only. So we get pi by 2. So if you come, if you subtract pi by 2 from pi, we get pi by 2, and which implies tan inverse x is equal to, so this 2 and this 2 will multiply, that becomes pi by 4. What is x value? Let's transpose tan inverse, so that becomes tan pi by 4. What is tan pi by 4 value? It is tan 45 degree. Tan 45 degree is x is equal to tan pi by 4 is 1. So x value is 1. Now the extension question for you all is, try this out. The question is 4 cot inverse x, 4 cot inverse x plus tan inverse x is equal to pi. Is equal to pi. Find the value of x. Find the value of x for this question. And this is an extension question. Next question. If x power y is equal to e power x minus y, so then dy by dx is equal to. So let's see how to solve this. First, I'll take the functions. X power y is equal to e power x minus y. E power x minus y. Now let's take log on both sides. Since we have function power function, we'll take log on both sides. So log x power y is equal to log e power x minus y. Log e power x minus y. So you all know the properties of log. Log a power b is equal to log a power b is equal to b log a, and also one more, log e the base e. The log e the base e value is 1. So by keeping that in mind, I will write this. Now log x power y becomes y into log x is equal to, here this becomes x minus y of log e. Log e. So already you all know. So log e value is 1. We get y log x is equal to x minus y. Now if we solve this for y, we get y log x plus y is equal to x. If you take y common, we get y of log x plus 1 is equal to x. So y is equal to x divided by log x plus 1. Yeah, so now this solved for y. Let's find dy by dx for this. So dy by dx is equal to quotient rule. It is 1 log x plus 1 the whole square. The same thing I'm going to write here. Log x plus 1 into x differentiation is 1 minus x of log x differentiation is 1 by x plus 1 differentiation 0. Okay, we get 1 by x and this gets cancelled out. The final element which is left out in the numerators are log x plus 1 minus 1 whole divided by log x plus 1 the whole square. Log x plus 1 the whole square. Here we can cancel plus 1 and minus 1. The final element that is left out is log x by log x plus 1 the whole square. That is option D is option C is the correct answer. Option C. Now I want you all to try this extension problem, that is y power x is equal to e power y minus x. Find dy by dx. Follow the same procedure and find the correct answer for this. Next question. The value of integral e power x of 1 plus x divided by cos square of x e power x dx is equal to. Okay, so if you see this function, this cos square of x e power x, I'm going to consider that is equal to t. I will write here x into x e power x is equal to t. Now, if you differentiate both the side, here we have to use product rule. We get x, I'll keep as it is. E power x differentiation is e power x plus e power x, I'll keep as it is. X differentiation is 1, 1, yeah, into dx is equal to dt. So we get, if I take e power x common, e power x, we get x plus 1 of dx is equal to dt. Now, in the question, if we see the numerator is e power x of x plus 1 dx, that we can replace as dt, and the denominator we can replace it as cos square of t. Okay, let's write that first. What do we get? The numerator, it is dt divided by cos square of t, cos square of t. Now, what is 1 by cos square? It is secant square t into dt. So we have taken a reciprocal of 1 by cos, that is secant square t. So integration of secant square t, we all know, that is tan square t. So tan t plus c is the correct answer, but we have to replace even t value, right? So let's replace that value. So the final answer for this is tan of t value is x into e power x plus c is the answer. Okay, now the extension question for this is similar like this only I will give you. I want you all to try. E power x of x square plus 2x whole divided by cosec, not cosec. I want you all to try this question. So the question is e power x of x into x plus 1, x plus 2 whole divided by sine square of x square e power x into dx. So this is the extension question. I want you all to try by using the same format and comment your answers in the comment section. Next question, the simplified form of I power n plus I power n plus 1 plus I power n plus 2 plus I power n plus 3. Okay, so before solving this, let's write some of the term. So I power 1 is nothing but I, and I power 2 is I square. I square is nothing but minus 1. I power 3 is equal to I square into I, right? I square into I. So we all know I square is minus 1 into I. It becomes minus I, and I power 4 is equal to I square into I square. It is minus 1 into minus 1. The answer is plus 1. So I power 1 is I power 2 is minus 1, I power 3 is minus I, and I power 4 is 1. Okay, that's very important for our problem. Let's write this. Next, I power n plus I power n plus 1. What I'll do is I'll write n into I. Like, if the bases are same, we can add up the powers. So I power 1, right? I power 1. Okay, we'll write I power 1 plus I power n plus 2. Once again, I can write it as I power n into I power 2. Okay. Plus I power n plus 3 can be taken as I power n into I power 3. Okay. Now, in all of this, there are 4 terms, right? 1, 2, 3, and 4. In that 4 terms, we have I power n common. We'll take that I power n. So what is left out? In the first place, it is 1 is left out. Plus, in the second place, we have I power 1. Plus, in the third place, we have I power 2. Plus, in the third place, we have I power 3. Okay, next, I power n of. So now one value as it is, I power 1 is nothing but I only. Now plus I square value is minus 1, right? Yeah, minus 1. And I cube value is what? I cube value is minus I. Minus I. Okay. Now for plus 1, minus 1 is a partner. For plus I, minus I is a partner. Okay. So what do we get? I power n of 0. So 0 into anything is a big 0. So option A, 0 is the answer. Now I want you all to try this. Same type I'll give you. I power n plus I power n plus 2 plus I power n plus 4 plus I power n plus 6. Use the same strategy and find the correct answer for this and comment your answers in the comment section. Now the extension question for you all is I power n plus I power n plus 2 plus I power n plus 3. I think this is enough. Yeah. So solve this problem by using the same strategy and post your answers in the comment section. Next question, the value of integral 2 to 8 root 10 minus x whole divided by root x plus root 10 minus x. Okay, so this problem, can be solved by using one of the log property, that is integration a to b f of x dx is equal to a to b f of a plus b minus x dx. That means, you have to add up both the limits minus the function dx. So let's solve how to solve this. Let's see how to solve this. Yeah, so I'll consider I is equal to 2 to 8 10 minus x divided by x plus root 10 minus x. Okay, now according to this property, x becomes the sum of two limits minus x, right? And here in this case, x becomes x is equal to 2 plus 8 minus x, right? So x is equal to 10 minus x. So now next in the further step, we have to replace x by 10 minus x. Let's replace that. We get 2 to 8 root 10 minus of 10 minus x whole divided by root 10 minus x plus root 10 minus of 10 minus x, 10 minus x. Okay, now if we solve further, we get integration 2 to 8 10 minus 10 plus x whole divided by root 10 minus x plus root 10 minus 10 plus x. So in the root, we can cancel this minus 10 and plus 10, and minus 10 and plus 10. What do we get? We get integration of, sorry, this is 2. So 2 to 8 root x whole divided by root 10 minus x plus root x. So I'm going to consider this as equation number 2, and the first one is equation number 1. Okay, so now if we add both of these, so in the left hand side, actually I is there. Okay, I have continued with I have not written everywhere. So I is equal to so now if you add left hand side, I plus I becomes 2i. 2i is equal to now this numerator and this numerator, if you add up, we get the limits are same, 2 to 8 root x plus root 10 minus x whole divided by, if you observe the denominators, both denominators are actually same. What is that? It is root x plus root 10 minus x dx. So in that case, this numerator and the denominator and the numerator gets cancels out. We get 2i is equal to 2 to 8 1 dx. Integration of 1 is nothing but x. The limits are 2 to 8. So 2i is equal to upper limit minus lower limit. So 2i is equal to 6, and I value is 3. So 3 is the answer. Now I want you to try this out. The question is, I'll just make a space. Yes. Okay, so the extension question for you all is I is equal to integration of 3 to 4 root 7 minus x divided by root x plus root 7 minus x dx. So this is a homework question. Try it out. After solving, comment your answers in the comment section. Next question, sine 1 degree plus sine 2 degree up to sine 359 degree value you have to find out. Okay, so let's write the series. The series is sine 1 degree plus sine 2 degree, so on. It is I'm gonna write two more terms before this sine 359 degree. Sine 358, okay, 357 will take, plus degree, okay, sine 358 plus sine 359 degree. Okay, now observe this 357 in the sense it comes in the fourth quadrant. So fourth quadrant sign is negative, right? This can be taken as sine 360 minus 357. 360 minus 357. So 360 minus 357 is nothing but 3 degree, right? Minus sine 3 degree. Okay. Now the second one, sine 358. Sine 358 can be taken as sine 360 minus 358. We get minus sine 2 degree. And the last one, sine of 360 minus 359 degree is equal to minus sine of 1 degree. Now, if you are going to replace all of these in place of these, we get, okay, let's write this, sine 1 degree plus sine 2 degree plus sine 3 degree, so on. Here we get sine 180 degree. You understand why the reason why I have written sine 180 degree in between. So on. It starts 357 degree can be taken as minus sine 3 degree. Next, I'll write here minus sine 2 degree minus sine 1 degree. There is a continuation. I've just written next line. Okay, so next, if you observe, sine 1 degree minus sine 1 degree, and this 1 degree gets cancels out. Minus sine 2 degree, sine 2 degree gets cancels out. Sine 3 degree, sine 3 degree, and sine 4, sine 4, sine 5, sine 5. If you continuously coming like this, finally we end up getting our important value, sine 180 degree. So there is only one term, which will be left out in this, that is sine 180 degree. So do you all know what is sine 180 degree? Sine 180 degrees, once again, your favorite value, 0. So option A, 0 is the answer. Next question. If A is equal to 3, 1, minus 1 and 2, so then what is A square minus 5A? Very simple question. Let's solve this. So first find out A into A, that is 3, 1, minus 1 and 2 into this 3, 1, minus 1 into 2. So if we calculate this, what do we get? 3 3s are 9, 3 minus 3, 3 1s are 3, 1 2s are 2. Next, minus 1 into 3 is minus 3, 2 into this minus 2, and minus 1 into minus 1 is minus 1, plus 2 2s are 4. Okay, we get 9 minus 3 is 6, 3 plus 2 is 5, this is minus 5, and this is plus 3, right? Okay, 3. So this is A square. Now 5 into A. 5 into A is, it is just multiply 5 to this. So 5A is what? So 5A is equal to 5 3s are 15, 5 minus 5, and 5 2s are 10. Okay, now if you calculate A square minus 5A, we get 6, 5, minus 5, and 3, minus 5A. This is 15, 5, minus 5, and 10. If you subtract, we get 6 minus 15 is minus 9. 5 minus 5 is 0. So this is 0. 10 minus 3 minus 10 is minus 7. Did I make any mistake? 5 3 is a 15. 9 minus 3. So 3 3s are 9. 1 into, oh, I made a mistake here. Sorry. It is not minus 3. It is minus 1, right? It is minus 1. 1 into minus 1. So it becomes minus 1. Yeah. So 9 minus 1 is 8. And next, if you replace 8 here, so what is 8 minus 15? 8 minus 15 is minus 7. Minus 7. Now, if you take 7 common, we get minus 7 common. Okay, minus 7 common, we get 1 0 0 1. So the answer is minus 7. This is the identity matrix, minus 7i. So B, option B, option D minus 7i is the correct answer. So very important, when you're solving MCQ, sometimes you will miss out some things like this. So it is better to come back and recheck all the steps that you have done. So here for this 7 minus 7i is the correct answer. Now if I give you an extension question, that is a is equal to 1 2 3 4 1 2 3 4. I want you to find out a square minus 7a, a square minus 7a. I'm not sure whether you get the answer like in the form of identity matrix. You end up getting a matrix, I guess. You consider that as a final answer. Whatever the matrix that you get it, that as a final answer. Next question. The differential coefficient of log x, the base 10, with respect to log 10, the base x. Okay, so let's see how to solve this. First, I'll consider u is equal to log x, the base 10. So we have to change the base of a log. Okay, so that's the reason I've written two different functions. So let's change the base of a log. U is equal to, if you change the base of a log, it becomes log x, the base e, divided by the actual base. The actual base is log, the base is 10, so it becomes log 10, the base e. So this is the base change property. Now we'll do the same thing even for the other one. So u is this, and v is equal to log 10 the base x, log 10 the base x. Now if we change the base of log, v is equal to, we get log 10 the base e whole divided by, what is the previous log, sorry, previous base, it is x, so it becomes log x the base e. So this is the base change property. Now let's differentiate. Now it is ready to differentiate. Let's differentiate. U is equal to log x by log 10. Sorry, this is log 10. Log 10, the base e and the base e. Okay, so now if you find out du by dx, here log 10 is constant, so I'll write 1 by log 10 as it is, the base e of log x differentiation is 1 by x. Okay, so this is ready. Now we'll take the other one, that is v is equal to log 10 the base e divided by log x the base e. Okay, now if you find out dv by dx is equal to log 10 is constant, log 10 the base e is constant. I'm going to keep that outside. and now it is 1 by log x. So it is function power n, that is function power minus 1. It becomes minus 1 of log x power minus 2 into 1 by x. It is minus 2. Just rewrite this before writing minus 2 into 1 by x. 1 by x, yeah, it's visible. So this is log x. So next I'm going to write one more step after this. So dv by dx is equal to, now if we rewrite this once again, now we get log 10 the base e divided by log x the whole square into x. The 1 by x multiplied to that, so it becomes log x the whole square into x. Okay, now if we find out dv by dx, du by dv, that is du by dx by dv by dx. We get du by dx is nothing but 1 by log 10 the base e 1 by x. Okay, we'll take like this into, I'm taking a reciprocal directly, children. Dv by dx is there, so the reciprocal of this complete term, that is x log x the whole square, whole divided by minus log 10 the base e. So what do we get? We get x and x gets cancelled out. Okay, let's cancel that by using different color. So this x and this x gets cancelled out. We end up getting minus of log x the whole square the base e divided by log 10 the base e the whole square, because log 10 into log 10 we multiplied, no? Log 10 the base e into log 10 the base e becomes log 10 the base e the whole square. Okay, so overall this can be written as, I'll write here, minus of log x the base e whole divided by log 10 the base e the whole square. So do we have this option? We don't have this option, so we have to solve further. Like how we changed log. Now observe this. Log x the base e divided by log 10 the base e, we wrote it as log x the base 10. That means, from base 10 to base e, how did we change? We changed, we wrote the function and we wrote e and we wrote the denominator. That is the base of the actual base in the denominator, log 10 the base e. Here the actual base is e. From this base to log 10 base, I want you all to convert. This becomes, if I write like this, tell me, is this okay for you all? Log x the base 10, log x the base 10 whole square, log x the base 10 whole square. Now, so this is what the final answer. Do we have this option? Yes, option B. Option B is the correct answer. So one small suggestion here. So just take log x the base 10. I'll just make a space for this. Yes. If I take only log x the base 10, so if you want to change this to log the base e, it becomes log x the base e divided by log 10 the base e, right? Yeah, so this is all, this is what we got here, and then we wrote that whole function as a minus log of log x the base 10 the whole square. So this is what the final answer. Option B, minus of log x the base 10 the whole square. So that is the answer. Now I want you all to try only the base change property. Okay, so just change the base of a log and differentiate. So just change the base of a log. Log x, the base is 12. So y is equal to log x, the base 12. I want you all to find dy by dx by changing the base of a log. I want you to find dy by dx by changing the base of a log. So this is your extension question. Y is equal to log x, the base 12. Find dy by dx. dy by dx. dy by dx. Next question. If A is 3, B is 4, and C is 5, each one of vector A, B, C is perpendicular to the sum of other two, then magnitude of vector A plus vector B plus vector C. Very simple question. So let's take, so the sum of each vector is perpendicular to sum of the other two. That means vector A dot vector B plus C is equal to 0, like this, since they are saying it is perpendicular, so the dot product of these two vectors will be 0. Similarly, b dot a plus b is equal to a plus c is equal to 0. So similarly, we get it, children. Okay, so now we'll take vector a plus vector b plus vector c, the whole square will take. So whole square is nothing but we can expand like this, no? A plus b plus c into a plus b plus c. Okay, here I'm going to consider only the same vector into same vector as one group and the other two as one group. So we get first one vector a dot vector a plus vector a dot, I'll take b plus c. Any of those values are zeros. That's the reason I'm considering like this. Plus now b with these three vectors. So I'm considered b dot b plus vector b dot c plus a. Next c dot c plus vector c of a plus b. So in the question already they have given, it is the each vector is perpendicular to sum of other two. Then if it is perpendicular, so this value becomes 0 and this value becomes 0 and this value becomes 0. So we end up getting magnitude of vector a dot vector a is magnitude of vector a the whole square plus magnitude of vector b the whole square plus magnitude of vector c the whole square. Actually what it is, in the left hand side we should write this, no? So vector a plus vector b plus vector c the whole square. Now these values are given. So a value is 3 square plus b value is 4 square plus c value is 5 square. So 3 square is not 6, it is 9 plus 4 square is not 8, it is 16 plus 5 square is not 10, it is 25. So it is 25 plus 25 is 50. Since we are finding out only a plus b plus c, so we have to find the root value. So if you take, okay, we'll write here vector a plus b plus c is square is equal to 50. So what is the final answer? So a plus b plus c is equal to root 50. Root 50 is the answer. That is also not there. We have to calculate further. So we'll write this as 25 into 2. So 25 into 2. So 25 square root of 25 is 5. So 5 root 2. So 5 root 2 is the final answer. So option C, 5 root 2 is the answer.
Subscribe for more content.
With this, I'm concluding the class. So if you feel this video was useful, please share, like, share, and subscribe my channel, children.
Subscribe for more content.